Million-mile battery. Tesla electric cars are, to this day, distinguished by reliability at high mileage. One such success of Elon Musk is the creation of a battery with a lifetime mileage of over 1 million miles, or 395 times around the globe at the equator. A stunning result. If you average 130 to 140 miles a day, then such a battery will last for 20 years of operation. That is, it is almost comparable to the resource of an internal combustion engine. How did Musk's team achieve such a phenomenal result? Recall the lithium battery, which can be called a modern hit in the field of saving electrical energy. It is used everywhere. It has a high energy density compared to other types of chemical batteries. But at the same time, it is impossible to make it large. Therefore, in order to achieve a large electrical capacity, it is necessary to combine many lithium batteries. The small size of the battery, combined with its high energy density, makes it a very dangerous object if misused. For example, under certain conditions, such a battery can become very hot, and thousands of such batteries can generate so much heat that they simply melt the car. So what's new with Tesla? In reality, the work was carried out by a group of researchers from Dalhousie University in Halifax, Canada, under a contract with Elon Musk's company. They did a lot of testing on different lithium batteries to find the best combination of chemistry, usage, and charging profiles. There is nothing revolutionary about the million-mile battery. This is just the same lithium battery optimized in size, electrolyte chemical formula, and design. But this does not detract from the achievements of Tesla. After all, the result is important, not how it is achieved. This million-mile battery is referred to in the data sheet as the 4680 battery due to its dimensions, where 46 millimeters is the diameter and 80 millimeters is the height. These are quite large parameters for a battery, especially in comparison with previous options. But such changes were fully justified, despite some problems. The biggest disadvantage of such large battery cells is their heating, but it can be completely fixed by radically redesigning the cell layout, which, in principle, was done by Tesla. The new type of battery has a number of advantages. If now the driving battery of an electric vehicle contains from 4,000 to 8,000 cells of the 18650 or 2170 type, then with the transition to the 4680 cell, their number will be reduced to 500 pieces. Also, the developers of this new type of battery claim that an increase in its dimensions has made it possible to significantly improve the main parameters. Thus, the energy in the battery pack can be stored approximately 5 times more, which will increase the range without recharging by as much as 16%. What's more, the cost of battery cells is 14% lower than today's. Also, since fewer cells are needed for the assembled battery, the savings on the finished battery are even greater. For example, if the battery components for an electric car cost roughly $100 per kilowatt-hour, then with packaging, controls, and cooling, the cost rises to $125 to $130 per kilowatt-hour. So the total savings when using 4680 cells can reach 20% or even 25%. An assembled battery for a modern electric car now costs $10,000 to $12,000, which is a fairly large figure. Tesla wants to bring the price down to $6,000 or even lower, which in turn will bring the cost of electric vehicles down to the level of conventional combustion-powered cars. This will make them more than competitive compared to conventional cars and will finally make electric vehicles the best means of transportation, which is essentially what Tesla founder Elon Musk is trying to achieve. At the first stage, Tesla plans to produce new generation batteries near the company's main plant in Fremont, California, for which a special assembly line will be built. In addition, the Tesla Gigafactory in Nevada will organize the recycling of used batteries to minimize the impact on the environment, which Elon Musk is especially concerned about. The new type of 4680 battery will allow Tesla to reduce the cost of electric vehicles as much as possible to a record planned figure of $25,000 by 2023. Tesla's first model with the new battery and a record price should be Model S Plaid, with a range of 1,840 kilometers an acceleration to 100 kilometers per hour in just 2 seconds. Impressive! But it should be understood that this million-mile battery is not primarily intended for passenger cars. When its developers claim a life of 1 million miles, they assume constant travel and battery charging after almost complete discharge. This mode is typical for trucks, robot taxis, and buses. The researchers used the term 100% DOD. For example, depth of discharge is when the battery is used all the way and only then charged, unlike, for example, a smartphone, which is put on charge every evening, regardless of the state of the battery. And in this regard, I immediately recall another brainchild of Elon Musk, Tesla's Semitruck, the production of cargo electric vehicles. After all, earlier the founder of Tesla claimed that it was the appearance of such million-plus batteries that would allow Tesla to start mass production of semi-trucks. Then Musk somewhat cooled the ardor of the fans. Asked how Semi is doing, he replied, "We are too limited in the production of battery cells, but maybe next year will be all right." And here is a statement from Tesla Senior Executive Vice President Andrew Baglino, who is in charge of power plants and power sources. Earlier this year, he said that this year, the company's ability to increase the production of electric vehicles also does not rest on the availability of 4680 battery cells. Already this quarter, Tesla hopes to begin selling the first Model Y crossovers equipped with batteries of this type. They are also assembled at a facility in Austin, Texas. Since logistical problems make it difficult to equip Berlin-assembled crossovers with 4680 cells, they will initially be equipped with 2170 batteries. And Elon Musk said that Tesla's ability to increase production of electric vehicles is currently limited by a shortage of semiconductor components, not batteries. So we hope that electric trucks will soon run around the world without these horrendous emissions typical of diesel multi-ton trucks. Tesla's 4680 batteries are not the only ones of their kind in the world. On the heels of the American company, their Chinese rival, VAC, is advancing. In May 2021, VAC presented their version of a battery of the same parameters, 4680. So, the capacity of one battery is 25 ampere-hours at a standard voltage for lithium-ion batteries of about 3.6 volt. In comparison, the compact 18650 AA batteries used in the Tesla Model S and Model X, produced by the same VAC, can hold as much as 3 amp-hours. By the way, the last zero in their name does not mean a length of 650 millimeters, because it is only 65 millimeters, but simply a cylindrical shape. Another new feature of the new VAC batteries is their resistance to self-heating, which is very important for fast charging with high power. So, the Chinese company claims that the battery of an electric car with their batteries can be charged up to 80% in just 15 minutes. It is also worth adding that VAC already has experience in creating relatively large cylindrical batteries. So, the company is already producing batteries of size 32105 and 32140. So it may well become the biggest competitor for Tesla and even overtake it. But it will be extremely difficult to do this, since Samsung SDI and LG Energy Solutions have already completed the production of 4680 battery samples for Tesla. Both companies are currently testing the manufactured 4680 batteries, with the intention of mass-producing batteries for Tesla's electric vehicles as early as 2023. But on the other hand, Chinese super batteries will certainly be cheaper than their American counterparts with comparable performance. And this factor can become decisive in the struggle for sales markets. We do not yet know how this race to introduce new generation batteries in electric vehicles will end, and who will win it. Perhaps, very soon, scientists will abandon the idea of solid-state batteries altogether and will look for ideas for new batteries in a completely different area. Be that as it may, we will closely monitor the news in this area. Subscribe to our channel and learn everything from their lips.